Hello, everyone. Thank you very, very much for attending my talk. It's very appreciated. The title of my talk probably sums it up quite nicely, so let's dive right into it. A couple of words about myself. My name is Oded Shopen. I work as a senior platform architect for Pivotal. I work out of our Israeli office. I'm mainly working with our customers, trying to help them achieve their digital transformation needs. Prior to that, I've been working as a software architect, mainly for big telcos, done that around 15 years or so. And I've really seen the change between, the transformations in our industry from things like WebLogic and WebSphere, moving to things like Spring Boot and Spring Cloud, and in the infrastructure level from, bare metal to VMs to containers and to platforms such as Cloud Foundry. And one of the main things that I really saw there is how microservices can have an impact on the organization, both at the technology level and at the organizational and cultural level. And that's really what I want to talk about today. So before we begin, let's try to reset and define what microservices are really, because I'm sure we all use this technology here and there. I'm sure we all have our own definitions. If you scour the web, you're going to find probably 100 different definitions. But I personally like this particular definition by Chris Richardson. He's the author of Microservices Patterns, a great book, and also Microservices.io website. And he defines microservices as the microservice architecture is an architectural style that structures an application as a collection of loosely coupled services which implement business capabilities. What I particularly like about this definition, which is actually a bit old, they actually changed it since then, but I like this one more because I like the fact that it focuses on things that are not necessarily the technological definition, right? We're talking about loosely coupled services that implement business capabilities. Now, if we were really to go out and try to implement this particular definition, you could say that you can do it even in a well-structured monolith, right? So here's an example of a shipping application, which I'll use throughout this talk. So this particular company manages shipping containers, actual containers, not Kubernetes containers, to transport goods all around the world. So it has various modules in its application. It manages the ports that it uses, it manages the cargo, it has a scheduling module, it manages the vessels, the actual ships, and it has a booking module for charging the customers. Now, you could answer the definition of a microservices architecture that I have shown in this particular microservices, in this particular diagram as well, because you can define the communication to be loosely coupled using things like in-memory events, things like Spring events, just implementing an observable pattern well in your application. And these components are well structured, so you can say that these implement business capabilities. But we rarely define microservices architecture in this way, right? This is a modular monolith. This is a well-structured monolith. How many of you actually seen one of these in real life? Good. So we have a few. Well, the reality is that in many cases, the monolith has a tendency to become spaghetti code, right? Or a big ball of mud, or whatever we want to call it. And the reason for that is clear. The reason for that is that it's hard to set the boundaries in this particular architecture. And as you go along and your spaghetti code grows and grows, and you add more team members and you add more people, you might even find yourself facing the spaghetti code monster at some point, right? Because at some point you can't really go back. It's too hard. So you actually replaced the meatballs with matrix code. It was a lot of work in Photoshop. So we rarely think of microservice architecture in this way. We usually think of it in this way, right? Just separate, isolated processes communicating between themselves using well-structured, loosely coupled mechanisms such as REST APIs for synchronous communication, or asynchronous communication using a message broker, something like RabbitMQ, something like Kafka, something like that, right? Okay, so we pretty much defined the what. What about the why? Why do we really want to go to such an architecture? And there are two ways that you can split it. Again, you can talk about the technology, and you can talk about the people. So let's start with the technology. What are the technological benefits that you would achieve by going to microservices architecture? I'll highlight just a few of them. Obviously, there are more in the interest of time. Number one is individually scalable components. So if we go back to our application, and we want to scale a specific component, such as the schedule component, because it has increased load, because more clients need to use it, it's very simple for us to go and increase the number of instances or scale it out horizontally as needed. If the bookings component needs the same thing, we can achieve that as well. This has a very clear side effect of achieving an optimal resource utilization. Because in the monolith world, if I want to scale one of these particular components, I basically have to scale everything, every one of these components. And this, of course, leads to increased startup times, because the entire process, all of the relevant components have to come up together just to serve maybe one particular use case that I have. And number three is independently deployable components, right? So that's pretty clear to many of us in this room. If you have a change request in a particular microservice, like the ports microservice, and you want to scale that out specifically, you can implement a V2 of the microservice and replace that without touching any one of the other components in your architecture. So that's a smaller production rollout, which is always a good thing. So that's pretty much it at a very high level. And I'm sure you're all sitting here and saying, wow, these microservices things, they rock, right? And they do. And obviously, when we go to this architecture, there are many benefits. But we always have to understand that there is no free lunch, right? Whenever you make a technology choice, there is always trade-off. There is always benefits, and there is always drawbacks. And in the case of microservices, it's a pretty well-known secret by this time. And the fact is that developing microservices can be challenging, right? And why can it be challenging? It can be challenging because developing distributed systems is challenging. That's just the nature of things. You just add more and more components to your architecture. There are more moving parts, right? Now it is 2019, and in 2019, you have incredible technologies such as Spring Boot and Spring Cloud, and you have the Pivotal platform. And I wouldn't recommend anyone going to a microservice architecture without at least some of these components in your arsenal. I personally try to run a microservice architecture in production using VMs, and scaling microservices in that way is not very fun, okay? So it's always useful to have a good set of tools in your toolbox to achieve your targets. But the reality is that you do add more chores to your technical debt. You have more moving parts. Now let's look at some of them. So what are those technology drawbacks that you have when you work in the microservices architecture? Well, if we go back to the monolith again, these lines that we see here in this diagram, these right here, well, these are just in-memory function calls, right? And these are great. They're great because they always work, okay? The target that you're trying to call will always be there available for you. And if you have any issues, most of the time you'll be able to learn about it at compilation time. You don't have to wait for runtime to figure out some of these issues. This also makes it much easier to test. End-to-end testing is a lot easier. Integration testing is a lot easier. And if you have any runtime issues, you get a whole stack trace, and you immediately understand exactly what went wrong. Now compare and contrast that with the microservices architecture. These lines right here, well, these are network calls, right? In the end, it's just network calls. And it doesn't matter what kind of network call we're talking. It can be REST, it can be messaging such as Rabbit, it can be reactive, it can be RSocket, whatever it may be that you choose to use. At the end of the day, these are network calls, and network calls have latency. And a target microservice might be down. It might be down because it's not responding, or it might be down simply because of a network glitch, which always can occur. So now what do you do? Well, now you have to start implementing things like circuit breakers. You have to implement retry mechanisms. You have to move as much as you can, offloading it to an asynchronous messaging, which sometimes you can't do when you want an immediate response. And if you want to have some better understanding of your application, it makes it a bit harder to test because you don't always have the target microservice available. So you need to do things like contract testing. At the end of the day, you might feel, I replaced my monolith with a microservices architecture, simply to have every outage feel like a murder mystery. And at every point when you are developing your architecture, you have to ask yourself, does it fit me? Is it good for my own specific use case? So in this case, you have to ask yourself, will I benefit from a microservices architecture? So let's look at these benefits that we saw before. Number one is individually scalable components, and that's true. And it is really, really great when you operate at scale. But when you begin, compute is cheap in 2019. Maybe the added complexity is not worth it when you just start out. Same thing for optimal resource utilization. It is true at scale, but when you're just starting out, you're gonna have to invest a lot in your infrastructure. You have to add things like config servers or API gateways, or a service mesh, or whatever it may be, distributed tracing, log aggregator, things like that. And independently deployable, absolutely. That's a great idea, that's an incredible benefit. But in some cases, you might have to support multiple versions of your microservices in production. So if you have 50 microservices, and you have to support 3 versions of each one, that's 150 microservices that you have to work with in production. So before you go and say, I guess it rocks, let me just clarify that this is just like any other technology that we are faced with, right? This is the Gartner research hype cycle, if you haven't seen it before, where it basically tells you that every emerging technology started at a peak of inflated expectations, and it ends at the trough of disillusionment, and then at some point, you reach nirvana, right? You understand trade-offs. You understand that no technology will be perfect for every use case. Some of it will be great, some of it will not be valuable to your own use case. And we're seeing it with everything. We're seeing it with things like Kubernetes. We're seeing it with things like serverless or function as a service, where we thought everything will move to this direction. Now we understand, okay, in some use cases it makes sense, in others maybe not. And we definitely saw that with microservices. In 2019, we already understand these trade-offs. And I think the number one thing to understand about microservices is that technology is just one aspect of the equation. The other one is people. Now, you can't really have a talk in SpringOne without a James Waters tweet, I believe. So he's mine. And he's saying, reasons for microservices paradigm shift is clear. Number one is to scale out commodity compute and hardware. But number two is to scale out software engineering. That's one of the main benefits that you achieve when you move to this architecture. To me personally, from what I've seen, this is a much more meaningful impact on an organization. Because for enterprises, this transition to a microservices architecture lives right at the intersection of technology and cultural impact. It's right there. So let's talk about the cultural impact. Why microservices? What are those organizational and cultural benefits that you would achieve? I'm going to highlight 5 in no particular order. There's not all of them. There are additional that I'll share in a link to an article at the end of this talk. But these are things that I personally have seen. Maybe you will understand them, maybe you'll recognize them, and maybe not. It depends on how you develop software today. So number one is focusing on a single module. So I'm going to use our famous shipping application again. And let's start with the Monolith. So I'd like you all to meet Dave. Dave is a new developer. He just joined the team, and he's really excited to get going. His program manager welcomes him to the team, and he tells him, well, our project is a monolith. It's been in development for many, many years. It's around 5,000 classes. It's around 500,000 lines of code that was developed along many, many years of development. And, well, basically, you're going to have to start understanding how all the components are working together, how the code is working together before you can really start contributing, right? Because in the end, these components have a lot of coupling. And it's very risky to start touching a particular aspect of the code if it might impact things that you haven't even been aware of. Now, of course, Dave has great team members, and they're all trying to help, and they're trying to answer all of his questions. But at some point, Dave is feeling rather frustrated. He's feeling frustrated because he does not contribute much back to the organization that he's working for. I've personally been to projects where onboarding took as long as 4 to 6 months. Okay, these things are real, they exist. And 6 months of not being productive is not good for the developer, and it's not good for the company that hired him. After a few months of not feeling productive, Dave is just feeling very frustrated, and at some point, he just decides that he's going to leave. Now let's see the same scenario in a microservices architecture. And honestly, my whole talk could have been summed up in 2 words, and these words are clear boundaries. Okay? Once you have clear boundaries, it's easier to operate people at scale. So again, Dave joins the company, and he's very, very excited. And his project manager welcomes him to the team, and he tells him, well, you're going to be working on one component, in one domain. It's going to be the vessels component. That component has around 200, 300 classes, a few thousand lines of code. It's going to take you about 3 to 4 weeks to really understand how things work inside this particular component of the application. Now, of course, there are other components that you're going to have to be aware of, but these other components, you can treat them as third parties. Right? These are just implementation details to you at this point. You talk to them via an interface, a well-structured interface. You don't have to dig deep into their code in order to understand how to communicate with them. Dev has a smaller team. They quickly become good friends. They go out for beers after work. Everything is great. After around 3 to 4 weeks, he does start to make his first commit to the project, and he's feeling very, very empowered to do the work that he was expected to do. Now, some of you might be asking, can you focus on a single module in a monolith? And the answer is, of course, just like some people said here. But you have to be very, very disciplined. That's the point, right? The problem is that it's very hard to find these clear boundaries when you work in a monolith. And whenever you work in a monolith, the spaghetti code monster is always lurking, waiting behind the scenes. Number 2, working on a separate code base. So, Git is great once you get the hang of it after a couple of weeks and you learn the 10 commands that every developer needs. And Dave's team definitely loves it very, very much. And everyone, they're sharing the same code base. Everything is okay. The monolith is working as expected. Occasionally, as time goes by, some of these more global classes are starting to make their way into the application. These red dotted lines there are what you'd call a global class, things like constant classes or utility classes, anything that you can think of as reuse, right? Whenever you hear reuse, you also have to understand you're talking about coupling. Okay, that's always the case. So as the team grows and the code base grows, it's getting much harder to commit your code. You're starting to step on each other's toes. Suddenly, Git merges become a daily routine. And we all know how Git merge looks behind the scenes, right? Ouch. Okay, so how would it work in the microservices architecture? Well, guess what? It's again about clear boundaries. That's all you have to know. So each team member gets its own repository. Each one works on its own code base. It can even be the same directory in the same Git repository. It doesn't matter. The point is that they are structured and moved to their specific code base that only they can touch, and no one else is prepared to use it. So they have a smaller code base. There's a less chance of stepping on each other's toes. And there are no global classes that everyone touches, right? If I can give you one message from this talk is, try to avoid sharing code between microservices. Even if it means that you'll have to duplicate some code, this means that you're going to have less chances of creating coupling between your microservices. You want to keep them independent. It's very, very important. And again, can you achieve the same result in a monolith? Yes, you can. If you are really disciplined, you can do it. Can you enforce it? Probably not. Leakage is a lot easier. At the end of the day, you're going to have leakage. You're going to have these shared classes. And people need boundaries in order to make sure that they are working as expected. Number 3, working in parallel. So we have Dana and we have Andre here, and they are working on the monolith. Dana's team is working on the booking service, and Andre's team is working on the cargo service. As part of a flow, she needs to call the check cargo API in Andre's development. Andre maintains this code. Now we created some sort of a dependency in our code. Now, even though the iteration started great and everyone were on track, those pesky human factors kept creeping into our development lifecycle. At some point, some developer got sick. One of the developers got sick. The DBA took time to update the schema in the database, whatever it may be, right? There is always a reason. At the end of the day, Andre feels like, wow, this is a problem. And then I understand that this line between the two, it's still a direct function call. It's within the same process. So this means that Dana has to wait for Andre to commit his code before she can really continue working on her own development. Now, at some point, she might want to try to do some mocks, and she might want to say, okay, I'm going to mock out this particular implementation, and it can get messy very, very quickly at that case. So Andre tries to commit his code because he feels the pressure, and guess what? He broke the build because he didn't do any proper testing. But he didn't just break his own build. He broke Dana's build as well, right? Because they're sharing the same code base. So that creates coupling. How will it work in the microservices architecture? Well, again, guess what? It's clear boundaries. So we begin by talking about an interface. Dana and Andre talk. It's a crazy idea. They begin by talking. Communication is key. It doesn't matter how you define your interface. You can use Swagger, you can use a JSON schema, you can use a Word document, you can use contract testing, whatever it may be. At the end of the day, they define an interface and they both agree on, and they get to work. Once they get to work, each team member goes out and starts working on his own implementation. We created a clear boundary, the interface. And again, just like before, Andre's team might take longer to develop, but it's okay. The interface remains the same. Dana might need to mock responses, but again, she's using a well-structured framework at this point. She can use things like Swagger. She can use contract testing, things that are well-structured as part of her development lifecycle. And again, Andre might break the build, but that's okay too, because it's his own build. It doesn't affect Dana at all. The fact that you don't have to worry about breaking other people's builds will allow you to sleep better at night, for sure. Number 4 is development excitement. Look, developers love technology, right? We all love technology. That's why we came here to SpringOne. We also love to explore new technologies. So imagine Dave coming to work, fresh out of college. His project manager tells him, welcome. You know, our application was built 15 years ago, just got bigger and bigger, and we just couldn't upgrade the technology stack as time went on. We're still using Java EE5, you know, and because of that, we're even using Java 5 behind the scenes. Some of our EJBs still use EJB2 with XMLs. We couldn't upgrade them yet to a proper version. And our front end, well, that's written in JSP. Dave looks at his manager, and the only thing that he can ask is, what year is this?
That's me.
Yeah, that's many of us. We've been there. Thumbs up. How will it work in the microservices world? Ideally. So Dave comes to the work, to his team. His project manager asks him, what are you passionate about? What do you like to do? You know, we have microservices written in Angular. We have some microservices in Spring. We're running some reactive programming. You know, we started exploring Kafka. We're even exploring RSocket in one of our microservices. And everything is running on a modern platform as a service. I'm sure, as you all agree, Dave feels like he walked into a candy store, right? Suddenly he can do whatever he wants. That's exactly what we all love. So why the difference? Why was it so different between these two? Well, the reality is it's hard to change the technology stack in a monolith, right? And the reason it's hard is because you have to upgrade everything. It's enough to have a single component that has a dependency on your legacy project or a legacy jar or whatever it may be, and suddenly upgrading becomes a challenge. Now, this is not just something that a legacy enterprise would deal with. We at Pivotal faced it as well when we tried to upgrade our Spring.io website from 1.5 to Spring Boot 2, right? We had our own dependencies on some technology artifacts that could not move to Spring Boot 2, specifically things related to Elasticsearch. So we're trying to move that now into its own microservice, so we don't have to deal with that anymore, and we can roll our own upgrades to the Spring.io website without any issues. We also had some issues with ASCII Doctor, if you're using that. The reason there was that it just brought a bag of dependencies that we didn't really want in our main code base. Things like JRuby and old dependencies that we just don't want it to contaminate our main process, right? So we're gonna take that and we move that into its own separate technical microservice as well. And that solved the majority of the problem. And by the time Spring Boot 2 was out, Spring.io website was already running with the latest version. And of course, in a microservice architecture, every process is a polyglot. So you might have your ports microservice running with Spring 2.1. You might have other microservices using .NET Core, whatever it may be. If it's based mainly on UI, you might decide to go specifically to Node and Angular. And if the cargo microservice suddenly needs a feature from Spring 2.1, you can work on that in isolation and just upgrade this particular component. And lastly, number 5 is understanding domain-driven design. So domain-driven design is not a new concept. It exists since 2003. Eric Evans' excellent book, I recommend you all read it. And it existed long before the microservice buzz was even a thing, right? And we don't have time to talk about what my DDD is in this short time frame, but the 30-second crash course is that it talks about the ubiquitous language. And the ubiquitous language says that if Dave talks about something and everyone else talks about something, they all talk about the same thing within a given domain. So for example, back to our shipping application. If you're talking about a real-world container, like an actual shipping container, well, in the cargo management context, we're going to talk about something that we use to calculate storage capacity. But in the context of a bookings domain, it might be something that we use to charge our customer. So that's the ubiquitous language within the bounds of the domain. So you might ask, okay, can you apply DDD principles in a monolith? And the answer is, of course. DDD existed long before microservices. Domain-driven design does not dictate an architectural style. Implement it in your desktop application if you want. It's up to you. The problem is that it becomes harder because the lines can get blurred very, very quickly when you work in a monolith. When you talk about domain-driven design in microservices, ideally, not mandatory, but ideally, a microservice can map nicely to a bounded context of a domain. So the cargo management microservice might be its own cargo management domain, and the booking microservice can be its own bookings domain. And the business people and the technology people can now talk about the same concept within a clear, bounded context of a specific microservice. It makes it much easier to communicate. So very quickly, I'll go through some of the drawbacks, and there are drawbacks to any pros and cons. Number one is that developers may push back, right? You have to understand that. You are moving the cheese to some of your developers. They will be unsatisfied. Some of them might even want to quit. You have to be empathetic. You have to tell them that you're going to ease into this change in mindset. It's not going to be a one-day rollout. Additionally, proper testing is critical because more of the issues are now pushed to runtime. So if you don't have good testing, you're not going to get much farther. Similar to that, good communication is critical. That's pretty much Conway's law. Conway's law says that any organization that designs a system will produce a design whose structure is a copy of the organization's communication channel. That's just a big way of saying that if your communication structure is good, your system will be good. But if your communication structure is bad, your communication and your system will be bad. And microservices just amplify this considerably. It makes it much harder to communicate. So, in conclusion, do what's right for your business. Microservices can help your organization go faster. A shift to microservices can result in better developers, better teams, and better communications. It's all about the people. And greenfield projects can start as a monolith. It's okay, you're allowed. Even in 2019, you have to understand when it makes sense to use microservices. If you are starting with a monolith, it's very important to place guardrails where possible to keep your monolith from becoming spaghetti code. And to that end, I highly recommend going to Oliver's talk, Building Better Monoliths, Implementing Monolithic Application with Spring. Sadly, as you can see at the time frame, this was yesterday, so either take your DeLorean and go back in time, or just watch it on YouTube when it's up. Lastly, apply DDD principles, regardless of your technical architecture. And move to a microservices architecture when you start to feel the pain. And please keep it simple, okay? Don't go crazy from day one. It will be a lot easier for you to take 5 mini monoliths and convert them to 20 microservices, just breaking them down, than it would be to take 100 nanoservices and try to merge them back into 20 microservices in the end. Because you most likely don't need 50 microservices. You have to really set expectations and start small and grow as needed. And lastly, enjoy the ride, learn and evolve both your architecture and your organization. Thank you for your time. This is the link to an article based on this talk. I'm here for any questions if you have them. Thank you.